So, good afternoon, everyone, and welcome to this afternoon's session. We're going to be focusing on finding and fixing, and in particular on in-pipe solutions and repairs. It's an area which hasn't been covered in detail at this conference before, but it's one that's absolutely crucial if we're to meet our shared goals of a 17% reduction in leakage by 2025 and tripling the rate of leakage reduction by 2030. Now, Jez Heath, who's chairing the first session, has spoken pretty compellingly in the past about the PALM methodology for addressing leakage, so prevent, awareness, locate and mend. And we've seen fantastic innovation in prevention and awareness with transient monitoring and mitigation and exciting data science. And we're making great progress in areas of locating leaks as well, with detection activity and advances in and leak noise correlation and satellites and drones. And we're going to hear a lot more about in-pipe technologies throughout this afternoon's session. But it's the MEND part of the acronym which has until now been largely untapped territory in terms of innovation. And historically, we've had far less representation at these sort of events from the people who are actually fixing the leaks. And it's great to see many more of those involved in repair represented here today as both speakers and indeed as delegates, as this is a really vital part of the jigsaw. So as things stand, we're still digging lots of holes to make repairs, and it's a pretty laborious task with a big impact on customers and communities. And we're digging up roads and having a big impact, of course, on colleagues who are doing that in terms of the hard physical labour required and the risks that we have to manage, particularly when working in the highway. And there really is a huge innovation opportunity here and multiple potential benefits. Firstly, quicker and more effective diagnosis and fixes that are far less carbon intensive, and ultimately things that really help us to meet our ambitious targets with the ever more pressing challenges as a result of the impacts of climate change and population growth on our water supplies. But crucially too, innovation in this area will help us to reduce the impact of fixing leaks on our customers and create that sort of happier, healthier and safer working environment for many of our colleagues. So along with the big questions of how we can tackle climate change, reduce carbon and meet the needs of a growing population, let's ask ourselves how we can modernise and really reinvent the process of finding and repairing leaks. How can we reduce the amount of those sort of manual interventions that we need to make? And how can we use the insights being generated from smart metering and the digital twins to support the find and fix? And how can we make sure that our commercial models for repair and maintenance are really set up to incentivise some positive outcomes and innovation rather than just incentivising the number of holes that are dug and the number of holes that are reinstated? And I guess it's finding answers to some of these questions, which is the big challenge, and it's going to require an awful lot of collaboration right across the supply chain. And this afternoon's session is very timely, actually, particularly while many of us are working together to develop bids for the Innovation Fund. There's a great opportunity to share learning and generate new thinking and new approaches, joining the dots between all the various different initiatives. And it's something we want and we really need to do as we keep those challenges in mind. So the afternoon's made up of a couple of sessions. There's the Soapbox challenge on finding and fixing for the first hour and a half or so. And then in the second half, we're exploring the outcomes from the leakage sprint at Northumbrian Water's Innovation Festival in 2020. So without further ado, we're going to kick off with the Soapbox challenge. Many of you will be familiar with this format from the previous annual leakage conferences. We have a series of short, sharp pitches with short Q&As that follow them, then a group discussion. And we really want to encourage you to put your questions on the right-hand side of your screen as you're going through, please. And I'm now going to hand over to Jez Heath, the Innovation Manager at SES Water, who's going to lead us through the session. So over to you, Jez.
Thank you very much, Peter, and absolutely agree with everything you're saying there. Of the need for this MEND side. When we first started looking at this and it was because we're very aware that awareness and location was very foremost in leakage managers' minds, but typically prevention and MEND wasn't. And really where we're moving towards is this idea of holistic leakage management, where we're looking at all of those areas. Now, I recognise, I think, for a lot of people listening in, taking part in this conference, you come from a leakage department backgrounds or you're part of the supply chain that are serving those. and therefore as a result of that it may be a bit more difficult for you to engage with this. But let me assure you, this is vitally important that we really start to look at this mend side and really understand ways that we can bring that down, and being looking for one solution that's going to solve everything. We know that leakage is complicated. What we're looking for today is to increase our toolbox, to look for solutions. You're going to go, do you know what? I may still be doing 60, 70, 80% of my repairs by that method. But for those other ones, those ones that run for 2 weeks because we can't get onto them because they're by traffic lights, okay, those ones that are real nightmares to repair, there's other solutions that are coming through. And we found that at SES. We've got some great solutions that we've been using. We don't use them all the time, but we use them in specific situations where they make a huge difference. So that's the kind of scope I think we're looking at today, is rather than looking for one thing that's going to fix everything, is start to think about increasing that toolbox. If you're from a water company, take some notes, go back and hammer your repair and maintenance side. Talk to their contractors. Why aren't they adopting these kind of solutions, which will make a real difference to the runtime of your leaks? If you're from the supply side at the moment, you're thinking, do you know what, I make loggers, I'm not really involved in this kind of side of things. I want you to start thinking about holistic leakage management. That's where we're moving towards, where all of those bits come together to solve leakage. And part of that is getting symbiotic solutions, whereby the work that you do pairs in really well with the repair side as well. So start to understand what's the constraints, what's the problems that repair are having, and how your solutions may be able to help that as well. So there we go. There's a bit of a pitch from me about the importance of doing this. And so what we're going to do is jump in right now. And the first presentation up is Michael Quinn from Aqua. Came across Michael a number of years ago. Great character. Really great story about how he came up with this original idea. I don't know if he's going to tell that one, but Michael, straight over to you.
I'll just get the slides up. So good afternoon, everyone. My name is Michael Quinn. I'm the Sales Director and co-founder of Aquanab UK. Just a little information, Aquanab was formed at the end of 2016 because we knew our ideas and innovations could transform and pioneer a new way of locating and repairing leaks in the water industry. Because of ageing water infrastructure being the main cause of leaks, we've targeted reducing leakage on distribution mains and also on customer supply pipes, which is actually responsible for up to 40% of all leakage. That's 1.2 billion litres of water each day. So as Jez said there, the idea first came about when my brother Mark removed an ink cartridge from the centre of a big pen, one of those. He then rolled up a small piece of tissue paper, put it inside the empty pen, and he blew. Now you may have noticed there's a hole halfway up a big pen, so when the tissue paper travelled through the pen, it became attracted to the flow of escaping water, blocking the hole. Now, Mark and myself were repairing leaks using traditional excavation methods at the time, but we knew this experiment was going to change our lives, and it has, because we're not digging holes anymore. So what is the Aqua and how is it used? Well, the Aqua is a patented free-swimming leakage reduction and repair product. It's handmade at our facility near Durham, and we believe the Aqua is the perfect product to be offered to the customer to be used as a first option to reduce or repair customer-side leaks as soon as possible, instantly saving water. The Aqua is RAS approved and made up of a 2-part polymer and a buoyant polypropylene core, and comes in 4 sizes and colours, and it's aimed at tackling leaks from 4 to 25 litres per minute. So to use the Aqua requires a simple criteria. Number 1, volume of leakage to be 4 litres per minute or above. This is the minimum flow requirement for the Aqua to be drawn to the leak. Number 2, the customer to be present, so the internal stop tap can be closed to isolate the supply. Number 3, a water meter chamber to be in place for the Aqua insertion, such as an EPCO chamber, APLAS chamber, or an MSM chamber. And number 4, the supply pipe size to be from 15 to 50 millimetres in diameter. So how is it used? Well, firstly, the customer's internal stop tap is closed. This isolates the water supply beyond the leak, so the only flow in the pipe is actually created by the leak. The water meter is monitored and timed over 1 minute to validate the volume of leakage is 4 litres per minute or above. The water supply pipe is then turned off at the meter chamber. The water meter and return valve are removed for access. The Aqua is mixed for 45 seconds, starting the curing process, and then wrapped around a buoyant core, which is now rolled into a P shape and inserted into the water meter outlet. then the non-return valve and water meter are put back. The water is turned on at the meter, and the meter must be monitored as the AquaP travels to the leak. So because the water meter is being constantly monitored, any fluctuations from the water meter will indicate whether the leak has been reduced or repaired. This is your window to see how the AquaP actually performs. Now, as you can see, the AquaP free swims through the pipe until it finds the leak. So the water meter slows down if the leak has been reduced, or completely stops if the leak has been repaired. After each AquaP has been deployed, the water supply must remain turned on for 15 minutes so the AquaP can cure under pressure and bond to the pipe. And if following a leakage reduction, the volume of leak is still 4 litres per minute or above, then the criteria is met for a second AquaP to be prepared and entered following the exact same process. So once the AquaP is cured in place, the customer's internal stop tap can be turned back on and the water flushed from a tap for 2 minutes. Then the customer's water supply is now back in commission and ready to be used. Now, this whole process only takes between 30 minutes to 1 hour and is simple and easy to use. The AquaP will save water companies around 70% of leakage from being wasted and running into the ground, saving on average 10,000 litres of water per day per job. A huge advantage of this is the amount of water and energy that can be saved quickly and easily, rather than the leak being reported, then going through the process of booking a team to come out and repair the leak. Because often water companies' median repair times for customer supply pipe leaks can range from 21 to 28 days until a dig repair team have been allocated the job. So you're preventing water, energy and money literally running away. I'd like to add, I cannot emphasize how important this product could be for water companies looking to achieve leakage targets, carbon reduction targets and improve customer satisfaction. Because for every 100 jobs AquaP is used on, 1 megalitre, 1 million litres of water is saved per day. And by saving this amount of water to be replaced from the treatment plant back to the tap, enough energy is saved to power homes every single day. Now, these results are achieved quickly and easily with 0 excavations, which will additionally reduce the carbon footprint even more. So the AquaP is already an award-winning product, having won Most Innovative Water and Wastewater Technology of the Year at the 2019 Water Industry Awards, and we're also in the final of this year's Water Dragons, which is being hosted by Future Water Association. So we've been testing and trialling with most of the UK water companies for the last 2 years with fantastic results, and have proven the AquaP to be fully operational and ready to be used on all quantifiable leaks. Now, we ensure every AquaP user has been trained on how to use our product, and we've trained over 200 UK water company leakage technicians. We provide training free of charge, and we're now training online, having trained over 60 technicians in the last 6 weeks with some great feedback. So I'd like to finish on the AquaP by saying this is the only free-swimming leak reduction and repair solution in the water industry, offering a new, non-invasive, groundbreaking method of reducing and repairing leaks without any excavations. Okay, now the Aquanab. Using the same concept as the AquaP, which is a product being drawn to the flow of escaping water, the Aquanab is a patented free-swimming leak locating technology consisting of a powerful transmitter encased in a sponge carrier and a handheld receiver. So just like the AquaP, the water main is isolated beyond the leak to create one flow in the pipe, which is the flow of water escaping from the leak. Now, leaks are often very difficult to locate in non-metallic mains and can cause huge disruption. But by pinpointing the leak, the Aquanab will reduce excavations, resulting in repairing leaks quicker, thereby saving water, reducing the amount of disruption to traffic and pedestrians, having fewer utility strikes and injuries, reducing the environmental impact from additional excavations, so therefore reducing the carbon footprint, and being cost effective. How is it used? Well, the Aquanab transmitter is inserted through a hydrant and flows along the inside of the non-metallic water main, emitting a signal from inside the pipe to above ground, which is followed at walking pace by the user until the Aquanab signal stops and is narrowed down, indicating the precise location of the leak. Now, once the leak position is marked, then a hydrant further downstream can be opened, and this will create a larger leak than the one the Aquanab has found, so the Aquanab will now travel to the larger flow of escaping water and can be retrieved from that hydrant. Often through time, landscapes change and as-laid drawings aren't updated, so this can create problems with not knowing the exact route of the non-metallic mains. But by following the Aquanab, then the route of the main can be updated. So following customer feedback and product development requirements, we decided to totally redevelop the app, and we'll be introducing additional benefits, including improving the visual display and operation of the receiver, technology to transfer water mains locations onto an app, and most importantly, we're reducing the transmitter size to use the Aquanab on pipes as small as 20 millimeters in diameter. This means the Aquanab will be able to be used on domestic, commercial and public non-metallic mains and supply pipe leaks. With Ofwat's new £200 million innovation funding competitions available, Aquanab are very open to discussing collaborations on any of these products or other water-saving innovations we have and will be developing in the very near future. I'd like to thank you for your time, and I hope you've discovered how beneficial our product can be for your company. Thank you.
Thank you, Michael. Really, really great presentation. What I'm going to do is we've got some time now, so we've got about 4 minutes still. So if there's any questions, please stick them in the Q&A. But as always, I've got a host of questions, which I'm going to fire at you straight away, Michael. So the really interesting bit for me is, I really love that idea. And it's the training bit. So I've always found that when we're trying to introduce something new, the training is really key, because if you get that wrong, used correctly, and things like that, how are you dealing with that? You said that you've got this kind of online training and things like that. How important is that training?
Yeah. It gives us confidence that our product's being used correctly when out there. We like to see that we offer certification. It's just a process to make sure that you get hurdles, you get problems that we want the user to be aware of. So it prevents any problems when they're out on site, basically.
Great, thank you. And material-wise, so you talked about the kind of things that it's really good at, and I know from experience that really you're talking about holes rather than splits. So where does that kind of take you material-wise? Where would you be recommending it for?
Well, as you said there, holes it does work better at, but which indicates copper pipes being the best sort of material to be used on. But we've had many fixes on black alkathene, galvanized, and even MBPE. So basically the splits, you will get more than likely get a reduction, but very often we repairs as well. And I think what I was trying to get across there to water companies is, if this product's used as a first port of call, as a first option, now you could be saving water from running in the ground for weeks and weeks. Even if you get a reduction, that can turn into many thousands of litres you're saving, litres of water that you're saving.
So there's a whole host of questions coming in about Aquanab, which is, so that's quite new. When have you introduced that?
It's been out for 2 years now, and we haven't had many trials done. It's not as easy to get this into trials as the Aqua, but we have had some success. But what we're trying to do now is, we know that the market out there is, everything's going to end up being plastic pipes, and a lot of it is already out there. So we want to target from supply pipes to hopefully transmission mains in the future, and we want this transmitter to be as small as possible. So we've decided now to totally redevelop it and add additional benefits as well to make it a better package.
Great, Michael. Look, what I'm going to do is I'm going to stop you there. All these questions that we've got about Aquanab, when we get into the Q&A session, I'm going to come back and ask you some more questions specifically about Aquanab. Have a look at the questions now so that you're ready on those ones. But let's have a little chat about that in the Q&A at the end here, where we can go into a bit more depth on Aquanab as well. Which then takes us, so that was 12 minutes, fantastic. And so now over to WRC, to Glenn, taking us through in-pipe solutions.
Thank you, Jez. Just bear with me while I share my slideshow. Okay, can I just check if that's visible? Can I just get a check if...
yeah, we can see that, Glenn.
You can see it. Okay, super. Right, so I'm here to talk about in-pipe solutions for the efficient identification and resolution of leakage in large diameter mains. So to begin with, I think a key message here is it's important to have a think about what's actually happening down there, because identifying leaks is one thing, but what you then do about it can be beneficial if you've been able to identify some of those other factors. So when you get into decision making, do you repair? Is there a weak section of main that you are then susceptible to further failures? What's actually happening is an important question when making that decision. There can be air pockets and gross metal loss on certain areas. There can be jointing issues. There can be all sorts going on. So what I'd like to talk about today is a bit about how you might think of it differently when it comes to large diameter mains. I think why just the large diameter? Well, historically companies have reported total leakage, not in all cases, but typically based on DMA leakage plus trunk mains and service reservoir losses. So in some cases that's been calculated using the bursted background methodology. Now it's pleasing to see, with firstly the new reporting methodology, but also the stretching performance commitments for leakage, that world is leaving us, and that could really be a disincentive for companies to actually go out and look for anything wrong with the network upstream of DMAs. Effectively, with the burst and background methodology, go and find more leaks, and it would reduce leakage and demand in real terms, but in terms of reporting could push it up. So that was one sort of development has been companies are pushing towards tile analysis. So there's a bit more focus now starting to shift onto upstream of DMAs, and rehabilitation of those mains is prohibitively expensive. So I think it's important to understand condition and performance. So I'm just doing a very quick run through of three of our solutions. So we've got Sahara, which a number of UK companies use quite frequently. So that's a tethered solution, inserted under pressure through a 50mm tapping, but can only go downstream into the flow with a range of a couple of kilometres. So that's 150mm mains and above. A couple of the free swimming solutions, Smart Ball, which that can be inserted and extracted under pressure through 100mm tappings, range of up to 40 kilometres, but minimum diameter there is 250. And then for really large pipes, Pipe Diver, that can be inserted, free swimming, 300mm tapping to insert in a range of 40 kilometres, but we're talking minimum diameter there of 400mm. So these techniques can be fitted with acoustic sensors for detection of leaks, but can also carry out CCTV, gross metal loss, and other assessments like conductivity. So yeah, Sahara. This, like I say, it's inserted, and we've got a couple of kilometre range with this. So the in-pipe sensor passes any leaks and allows detection of the noise and confirmation of where leaks are. So it's got a tracking system in place to sort of avoid false positives. Operatives undergo typically around 18 months of training before they carry out surveys, and this can give indication of depth as well. And there's been over 15,000 Sahara surveys completed in the UK. Push rod, just a slight variation here. This is where there is no flow present in mains and there's a need to inspect, or you need to survey against the flow. So I think that can be some difficult to access points, can be quite useful if you want to gather CCTV or do leak detection in those circumstances, access being a key issue. In terms of enabling works, then just not going to dwell on this one, but there are different options available. Access is something that can put people off, so we do advise on suitable techniques to reduce the enabling costs. So we can go through via through-bore hydrants. There are other solutions such as Hydrant Wizard. Existing assets such as air valves can be adapted. So that's the message there, is just talk to us if you're interested in this type of survey. So quick case study of using Sahara. There was quite a pressing time window here, so an 8-hour window. with a fire main with no flow. So this had to be isolated from pumps. Sahara had to be inserted, the fire main was repressurized, and the survey was undertaken to coincide with the low tide. So that was the key constraint, was tide timetables. The leak was found and marked up, survey equipment retrieved and extracted, and the fire main was back in service on time. So just a sort of an example, this can be done under quite tight time constraints. Also worth just mentioning raw water. We always tend to focus on everything that's come through the distribution input meters. This is just an example of raw water mains with zebra mussels located using CCTV, causing blockage, etc. So I think just a very quick message there. Don't forget about raw water. Doesn't necessarily hit the performance commitments, but in terms of water resources planning, just might be one to think about. Losses prior to the DI meters. Smart ball, so that can go up to 40 kilometers, free swimming, and typical leak location accuracy within 1 to 2 meters. So again, this really depends on if you're trying to decide which techniques, depends on constraints such as what type size of pipe are you looking at. If you want to get a longer survey done, then the number of access points can be greatly reduced, but it really depends on the configuration of the network. So this has got a gyroscope. It can detect things like air pockets as well. It can help validate GIS data. So if you're not entirely sure where the pipeline's running, then SmartBall can be useful for tracking the pipeline route. Pipe diver as well for the really large mains. So this is the 300 and above mains. So you can see from the image on the bottom left where it identified some quite significant corrosion. So the big question, why does all this matter? In normal distribution size mains, it's expensive when you dig holes and go to do repairs. Even more expensive when we're dealing with large diameter, so there's a more pressing need to make sure the leak detection is accurate. But also then we're on to the questions around asset management. What does it actually mean? What do you do? If you repair it once, are you going to be back there dealing with the same main again? And as we all know from the stories in the media, trunk main failures can be particularly problematic in terms of impact on wider society and the public more generally. So actually understanding what's happening, do you need to replace a whole section? That starts to become expensive. So in this sort of before and after, it highlighted a few areas here where there were a lot of sections of this pipe that had no issues, no anomalies. It was just a few areas there that required attention. So full rehabilitation of that main wasn't required, but there was much better insight and understanding after these surveys. Just finally, people sometimes approach us and we don't always get the dots joined together. So I think thinking with an asset management hat on is the message. We can offer asset management solutions to go with the in-pipe assessments. So it's sometimes worth just joining the dots. It's not always the case. Some companies are quite happy just to say we know our assets, we know what we need to survey. Others that perhaps haven't got that level of understanding, then we again quite happy to work in an asset management capability. And I describe a process we've developed to support these tools as asset management light. We're not really too concerned about forecasting 20 or 30 years in the future in terms of how the large diameter pipes are performing, but we do run some ArcGIS processing just to start to help identify some of those areas that might be priority targets for surveys. So just to summarise, we've got video links. I'm not going to play them now, but they are available on YouTube if people are interested in finding out more about these solutions. So the key message here is it's not always just about finding and fixing. It's that understanding of assets, and can you actually, in the process of finding a leak, just do that bit more to perhaps help you prevent the next leak from occurring, particularly where the the consequences can be quite severe in leakage terms, but also disruption, interruption to supplies, and damage to property and those type of issues. So thank you for your time, and that's my slides finished.
Thank you very much, Glenn, and that's almost exactly on time. I'm just going to ask you one question, and we'll come back to some others in the Q&A. The smart ball, what happens if you lose it? Okay, that's always the concern in terms of our networks. We're putting something in. What happens?
It's a good question, and to my knowledge, we haven't lost one yet. So I think the process is pretty robust for capturing that as it moves through the system, and it is tracked as well. So if it does go missing, locating it shouldn't be an issue.
Brilliant. Okay, look, there's some questions come in. We'll pick those up in the Q&A going onwards. But thank you very much, Glenn.
Thank you.
Over to our next presentation, Fabio from Piper, and he's going to be talking about in-pipe leak detection and leakage solutions. So Fabio, over to you.
Thank you. Okay, can you hear me?
Yes, we can, Fabio, and we can see your slides.
My name is Fabio Orlandi, everyone. I'm the commercial director of API and People Limited. So basically, API is our service company that offers global surveys on water mains, and also the trainer for People Technology. People specialises in pipe inspection technology and leak detection tools for global markets now. So everything I'm presenting today is not a prototype. This commercially available tools we've used over the past 12 years. So working out the UK markets, it's been a great playground for us because they're very stringent on health and safety, hygiene in water, especially drinking water, and we've approved everything for safe use of potable networks. So technology we have today covers all size pipes. So we worked on service pipes up to a very large diameter trunk mains, and more recently our biggest market seems to be the new pipe installations. So traditional technology on the marketplace today for leak detection, well, you know, there's limited factors that whether using correlation, loggers, tracer gases, they've all got the place in the toolbox, but there's also factors external to this, you know, whether it's ground conditions, location, external sounds. So we've gone to the markets. Everything we do is basically specialized in in-pipe inspection. So you can work in all materials, all pipe sizes. You'll find in the leak as it exits the pipe, you know, it's sort of in the pipe and showing where it's going to be. So this is a real study here where top sounding of a leak is not always present on non-metallic pipes especially, and water always finds its own path. So this job here we're showing on the screen was the hydrocam was used, our insertion tool, where the leak was 22 meters from where the water was showing. So, you know, it's not always a top sound approach is the way forward. So being inside the pipe with technology, you are passing the actual leakage point. So all of our platform tools on the marketplace are basically inserted into the pipe. They're basically external, it's internally done, live audio out of the system. Everything's sanitized and chlorinated to the network. It's all basically traceable as well. So we'll talk about mapping pipes, we can trace these technologies. A bit of a case study or project now we're involved with heavily in the UK is Welsh Water. They're the first UK company to look at zonal studies of the network. So they're looking at every single asset on the network to prioritize where they spend their money. So whether it's basically is a pipe lined or unlined, clean or dirty, confirmed size and material. All this data is vital for planning your next step in the rehabilitation of pipe networks. So other services there on the network is some illegal connections for Project Overseas. And you know, reasons why I use technology, well, there's numerous reasons where it's knowing what's down there from GS, looking at buried valves, leak detection, checking materials, blockages, closed valves. There's numerous reasons this technology is really vital before you start digging and cause excavation headaches. So into the bigger size pipes floating system, this is the flow rider. So it's inserted into the pipeline similar to other products, but it's a combined camera, acoustics and traceable system. We've also modified this unit now to be a collapsible chute. So you can float down 1,000 meters in high or low flow rates now, collapse the chute remotely and pull the sensor back. So that's a massive advancement into technology today. Flow riders are one insertion point, small footprint, so small chamber required at ground level, so like a through-bore hydrant or direct tapping. Basically, it's all battery powered, so silent operation, remote operation. This can be used anywhere in the world, you know, with no external power required. Then it's the bigger system we've got now for large mains is the Pluto. This is a tethered device again for inspections of large diameter pipes. We made it a 2 kilometer system from the start. However, last year the first project we won with this system was in Hong Kong, and it was a 4.3 kilometer survey, so we can do further distances. The bonus of this technology is you've got the camera system, the acoustics, and the actual extra lighting, but also telemetry there. We've added to it temperature sensors, pressure sensors as well, so you can basically do a nice graph to show the client peaks and troughs in pressure on a pipeline, and also check the temperature of the water throughout the survey. So a lot of data on there, and some images there of the actual system there. So basically, you insert live into a network, you float down a chute downstream, you extract it live, and then pull a sensor through the network. New main leak detection. This is the Pipebot hydrostatic. So this is made for up to 2 kilometers around as many bends as you like, to basically be a fail-safe on all new pipe installations. Believe it or not, new pipes are failing every day, and the delays and cost is absolutely astronomical. So basically, this is inserted into the pipeline with a swab as part of the build process, and then cleaning process, and the sensor is pulled through to find leaks accurately. From this, we jumped into camera surveys and new mains, so we're calling this PCI inspections, pipe commissioning inspections, to give the client the actual confidence in the quality of the installation, and also the actual checking for air pockets, debris in a pipe, make sure the pipe is up to standards. And recently we won projects overseas where instead of swabbing a pipe to clean it on new mains, they're going to install our cable as part of the build process and build this cable within the pipeline, and then pull the camera through for inspection, chlorinate the same water, and put it into service. So the millions of gallons of water that we save now from this technology is actually huge. And then the Pipebot flow rider. So this is a floating capsule up to 5 kilometers to do a leakage sweep within a pipework. So this has gone to many countries now on drinking water mains and also riser mains. It can be used as a riser main assessment tool. The cable itself, we're now pushing as a permanent installation as well. So this system is approved for materials in contact in drinking water, and it can have a 5-year life in a pipeline. So any high-risk locations, this can be stored into a network. The software we have as well is now scanning through the data. So a year ago, 12 years of audio was listed in the office with the operator. Now the data is scanned through quickly within 30 seconds to give you points of interest. So this image shows you an actual leak found on a network. We also make water tools for the industry now. So we've made cleaning tools for hydrants. We've made injection devices for loose jumper hydrants, which is industry first again. So you can keep custom supply now with all type of fire hydrants. R&D solutions, we're talking about budgets available for R&D. Well, we're happy to collaborate with any company out there on any solution you deem necessary for the industry. New solutions we're working on now is basically, there's a few. There's a live boundary box replacement tool, which is costing people millions of pounds to replace boundary boxes when a 2-pound valve is faulty. So instead of replacing the box, we're going to replace the valves live. A live installation strainer for discoloration. So water complaints can now be solved by a temporary or a permanent installation of a straining device directly to a network. We're working on a hand tool solution for the industry as well, to give you more torque when unbolting and bolting flanges on a water pipe. And also the in-pipe solution. So we've been approached by many companies now to offer a solution for in-pipe repair. So we can see the leaks, we can hear the leaks. Why not repair the leaks? Some case studies here. So this is a job in Scotland on a hydro scheme where the client was losing a lot of money every year with his hydraulic output. We did a 3.5 kilometer survey with a flow rider, and we found, as the picture on the left shows, the pipe has imploded or gone flat, and the joint is now leaking, costing a lot of money per year. This one, another one. This is a new main solution we didn't mention earlier. This was basically a job in the UK. This main failed its test for 18-month period of time, and the cost calculation was £250,000. We found the leak within half a day using our technology. So a great fail-safe on all new assets. And then the Hong Kong project with Pluto. This was a 4.3 kilometer survey, a tethered survey into this network. And basically we're saying, look at your pipelines, confirm internal condition, remove the unknown pipe issues, and then listen. So in-pipe solutions, acoustics, look at points of interest and verify points of interest. as already mentioned, most leaks on large diameter pipes happen over many, many years. You know, a pinhole leak eventually turns into a failure, and once it fails, that's where it goes from thousands into millions. So find the leaks now and then repair the leaks now using this technology. And then people technology, innovation, knowledge, and training. Many thanks. Any questions?
Fabio, and I will be many slides you had. I actually said to someone, if he gets through all of those in time, I will eat my hat, and it looks like I now need to eat my hat. That was very impressive. Thank you. Look, I'm really interested in some of the stuff you've been talking about, particularly the work you've been doing on brand new pipe.
Yeah.
Because I see that as a huge issue in our industry, that we seem to be unable to lay plastic pipe that doesn't leak. Yeah. So, you know, talk us through what your solutions are doing on that, and what you're finding. Where are you finding these leaks on this brand new plastic main?
Well, we've pushed this in the UK markets. We started this about 4 years ago when a client had a failed new main, and we basically had a solution with our push system, HydroCam, and we were finding leaks. However, we were saying, well, you know, we're pushing 20 meters this way and 50 meters this way, which is all you'll get with a push system. And how long do you need to measure? And they said, well, 1 kilometer. So we made a 1 kilometer device. Great. Problem we had was the first job they gave us was 2 kilometers because of behind schedule. They put 2 schemes together, so I had to redesign the cable, the seal houses, etc. So now it's standard out the box 2 kilometers. But what we find is typically the actual installation conditions. So a lot of these sites are new roads, big new motorways, and the sites are such horrendous conditions with weather. And so it's the joints basically, misaligned joints, failed couplings, even down to design issues. You know, it could be like a thrust pot required where it's not been installed.
And you showed that slide quickly, and I think I'm going to have to go back and look through your slides to see this one more. But this right. What I'm going to call a smart swap. This idea of you have a cable, yes. They lay a cable and put it through. So talk us through how that works. You've got like 2 minutes, but just talk us through how that works. Is that able to find a leak that's actually
so basically the system was made at the start. We put building the cable within the pipeline, and then every water company since then says we don't want that. We want to do this, build the pipe, and then swap the main as they do to clean the pipe, and then do the testing. So we went on that approach. We give you the cable, we give you the seal housing, and you do that installation. The issue then was, well, you know, all the water wasted on swabbing these the millions of gallons around the world a day are wasted on swabbing pipelines. So what we said, well, let's go back to the basics then. We give you the cable, you pull a section together, and you pull the cable through. Now, we're winning work around the world now on the cable and the system approach that way. They build the cable in the pipe, you know, pressure test it. The client is told that we're going to survey the pipe afterwards. So they've got quality control in place already. We're independent. We'll say, well, we'll check the internal condition. We'll check the joints are hosed correctly. We'll check with acoustics for leakage. We'll check for trapped air pockets. So all this data, we'll say, we'll pass this pipe's clean bill of health. We'll do its pressure test. We'll chlorinate the same water. So there's a huge, you know, environmental impact on one system alone, you know, with the camera and the pipe pod system in there. So.
Fantastic. Thank you, Fabio. And I can see questions coming in already on these. We'll come back in the Q&A session, but thank you so much for that.
Yes, thank you.
So excellent, Fabio. And so moving on to our next presentation from Nicole and also from Kirill as well. And this is Pipebot. So this is another fascinating one. Every time I go along to conferences and things like that, and they do those kind of networks, they do those kind of workshop sessions on how to solve leakage, I generally time it until someone says robots in pipes. But here we are, robots in pipes. Nicole, Kirill, over to you two.
Thank you very much, Jez, and welcome to this presentation. So it's so my name is Nicole Mitya. We've also got Professor Kirill Horoshenkov on the call. That's the University of Birmingham and Sheffield represented, but there are other universities involved in the project, as you can see at the bottom. Just to give you a bit of an idea, what is Pipebots and what's the aim? So really, the aim is to design micro, so it's very small robots, swarms of robots, to go into our underground pipe networks and to live in our underground pipe networks. And really, the idea is to revolutionize the buried pipe infrastructure management, because these robots are there permanently or semi-permanently. They communicate while they're in the pipe, they charge while they're in the pipe, and they basically just live there. And ultimately, the vision is that they could also actually do repairs. So as you can see, this is a sort of research project. It's funded by the Engineering and Physical Science Research Council. It's what's called a program grant, which means we've got quite a long time to do this work. So it's a 5-year project, started in 2019 and is due to finish in 2024. It does involve 4 academic institutions, as I said, 2 represented on this call today and in the conference. But it's got over 40 researchers working on that problem, with well over 30 industry partners. And we don't just look inwardly, we also look outwardly. And that's not just in the UK, but that's also overseas. So we're also working with our international partners as well. So what are we actually trying to do? So really, what we're trying to do is develop some new science, specifically on the sensing aspect. So the project, you can't quite see this because it's quite small, I bet, on your screen, but you can see a bigger version on the website. So the project is split into 8 themes, where 5 of the themes really look at the technology element, and 6 of the themes look at the technology aspects, and 2 of the themes look at broader issues, which I will go into in a bit. But it's really trying to combine advances in robotics, advances in navigation, and advances in communication to come up with a solution that works for the quite challenging subsurface infrastructure networks and the environment down there. So the aim is to advance this from the laboratory prototype to field scales. Some of you may know that a lot of the UK universities had some funding through something called UCRIC, or UK CRIC, which stands for UK Collaboratorium for Research on Infrastructure and Cities. And as part of this, both Birmingham and Sheffield have some big laboratories built where we can actually do near full-scale experiments. Clearly, we can't make it as complex as in the real world, but we can actually try quite a few things out. One of the key aspects of the work that we're trying to do is to actively engage with our end user community. And as Jess already mentioned, he's been to some of those events, and I'm sure some others of you who are on the call have been to some of our events. If you haven't, we've got a website, we've got contacts, which are on my final slide. So please do get in touch if you haven't heard about it or want to find out a bit more. I should say that it wasn't just a whole bunch of academics sitting in a room who dreamed up this project. We actually held what's called co-creation events, co-creation workshops to really derive the research. And really what we're aiming to do ultimately is to develop a world-leading research center of autonomous sensing for buried infrastructure. One of the things we're doing is we're going through a number of sprints, and a sprint in our case means something where we work on a specific problem for a very short period of time. And one of these problems was, can we actually, in say something like 4 to 6 weeks, can we actually develop a sprint robot? So in that very short time, can we develop a prototype robot that can actually function and do a few certain things? So we were successful, and what I'll show you now is a short video of our sprint bot. So you can see our sprint bot at the end of a pipe, a drainage pipe. It's trying to find its way in. It's moving along, so it's not just a robot that was moving along, it also had some sensors on it, was sensing something. It's ending up in a manhole, and it's successfully actually finding its way to the next outlet. You might wonder what these springs are at the end, so at the tail here and at the other end, that's so in case it falls over, it can right itself. So that's quite important for us. And there it goes again. As you can probably see from the pictures, this was clearly somewhere above ground. So this was a very simple network that we put up above ground. But what are the lessons that we learned from there? So there were a few lessons that I share with you. And as you might have already seen from the dimensions or had some guess from the dimensions of the sprint bot, it's rather large. but it fits successfully in 300mm and 240mm diameter pipes. At the 210, it's struggling a bit, as you can see on the image. It can successfully handle T and Y sections and get in and out of manholes. It was clearly a very simple robot, and that's really the aim of these sprints, is really to come up with a very quick, maybe quick and dirty solutions, but to get the whole team working together towards something. The robot was controlled using a simple app on a mobile phone, as you can see at the bottom. It successfully integrated the electronic systems, and it actually integrated the sensors. And one of the lessons that we learned is that a modular system is really successful because, or has advantages, because we can switch things in and out as we develop them further. So that was quite an interesting lesson learned. I appreciate this is a very quick overview of what we're doing. So one of the other aspects that we are doing is, these are themes 7 and 8, is to look at emerging science and systems and use system knowledge, and also end user engagement. And really what this is trying to do is to not just look at the technology that's important, but also to understand and map the dynamically evolving infrastructure and urban systems with which it interacts. So it's not just looking at the buried pipe infrastructure in isolation. Clearly, it's also trying to horizon scan and look at other technologies that emerge, not just from the buried infrastructure management, but also others. But it's also looking at the political, economic, and social environment, and make sure that whatever we develop actually seamlessly integrates into practice. So that might mean changes in business cases, or considering alternative business cases. That might be looking at regulations. The other thing that we are looking in that aspect is to support the testing, the validation and demonstration of new sensing and inspection technologies at full scale in realistic environments. So if we can create a test facility where the likes of the presentation we've just seen, where people can come and test and we can evaluate different systems against each other. We're also trying to develop algorithms to synthesize collected inspection data. So it's one thing, obviously, getting the data, but it's also the making sense of the data. And also, finally, ensure that autonomous robotic inspection technologies are adopted so that they can really lead to a step change reduction, asset failure, and loss of service. So one of the things I was asked to mention is, what are the challenges? And I'm sure this doesn't come as a surprise to most of you. One of the challenges is clearly the miniaturization of the robot, so making it small so that it can actually go into your 100mm or even 50mm pipelines. It's the communication and data retrieval, because we know that communicating through RF, through the ground, is quite difficult. So radio frequency signals through the ground is really difficult. So how do we get the data out? But these robots, so we've seen some examples of tethered robots. We are trying to have autonomy in our robots and have automatic navigation. We want to ensure that there's no impact on the flow, but also we're not just looking at potable water, we're also looking at drainage and sewer systems. So therefore it often has to operate in wet, dry interfaces. So where you've got water at the bottom and dry at the top. But it also has to be agile to cope with the mobility within, agile to cope with the different networks. And finally, before I get to my last slide, we identified 4 case studies. These are the ones we're working on the most, what the robots are aimed at. That's blockage, asset management, asset mapping, condition assessment, and as a subset, there's leakage. And finally, coming up, I've already mentioned this, there's clearly a big opportunity for collaboration. There are lots of things that we need your help with. If you've got any questions or want to find out more, have a look at the website or send us an email. Thank you very much.
Thank you, Nicole. Great presentation. And yeah, really, really interesting to see how that one's developing. So I think, yeah, it's really interesting that you finished with the challenges, and it was great to see where you've got to. So let's talk through some of those ones. And firstly, the obvious one, I think, to everybody sitting here is the challenge of introducing that into clean water environments. How do you feel that will go?
Well, I think, I mean, there are some existing regulations out there, and I guess being a research project, while we're keeping that in mind, it's not our main focus of the work. We want to have a proof of concept that we can have a swarm of these mini robots in our pipe system, and therefore they can operate autonomously in there. But what we're doing is we're investigating what materials we're using, and so to ultimately get them into our systems.
And that kind of leads neatly into the second bit there. You just talked about robot swarms, and that's one of the really interesting applications, I think, is the idea that you could have multiple robots going past the same point. You get a lot of additional information from that. Is that correct?
That's correct. And the idea is also that maybe we have got robots that perform slightly different tasks and they communicate with each other. So it might be that a robot has a certain sensor on it, indicates a problem, communicates that to a different robot. That robot might actually go to that particular point and investigates it a bit further, or with other sensing technologies to get a bit more information. So it's not just a duplication, it's also maybe utilizing different specifications for the individual robots.
Thank you very much, Nicole. Excellent. Fine. So again, we'll come back in the Q&A and kind of have a longer discussion on this one. There's a whole load of things that we're coming up with, but a final presentation now. And this is from another Jez. Here we go, Jez Parker. And from Mike Wild there from MW Polymers. And they've got a really interesting for this. I was really impressed with this because this is for me, I'm not going to say no tech, a simple tech solution to a real issue. I think, but go ahead. Over to you, Jez and Mike.
I can't hear a thing.
You're on mute, Jez.
Hello, can you hear me?
Hello,
Yep.
Good afternoon. Can everybody hear me?
We can.
Okay,
Yes,
so
we can,
my name's Jez Parker, and joining me on the presentation this afternoon is the founder of MW Polymers and managing director, Mike Wild. So today we're presenting the Aquatight water clamp, an easy fit, cost-effective repair solution for the water industry. Could I have the next slide, please? Could I have a slide? Thank you. So MW Polymers have been manufacturing leak sealing products, mainly for the gas industry, for the last 40 years. We also have experience of sealing liquids in the chemical and food industries, and we develop unique solutions that are manufactured in-house using our own resin formulations, some of which are patented. Our systems are approved to a technical performance standard, including a 50-year life test. And our global customer base includes all the UK gas utilities, as well as customers across Europe, Asia, Australasia, including the likes of Hong Kong and China Gas and New Zealand gas company, Electrics. And the next slide, please. So to establish the features required in a design for a better water leak repair method, we looked at the extent of the problem. Our latest research of the water industry revealed in a UK survey there were 48,000 kilometres of pipe that had 78,000 water leaks. Most were on pipes of 250 millimetres diameter or less. And of these 78,000 leaks, 60,000 were circumferential breaks and 18,000 corrosion holes. So that gives us some idea that we need to create a clamp for pipe breakages and pinhole corrosion. So if you'd like to go to slide 4, and Mike will take you through the product itself. Thank you.
Okay, hope you can hear me. Yes?
Yes.
Okay, so hello everybody, I'm Mike Wild, and during our 40 years of sealing gas leaks, we know from the sites that we visit that and carry out repairs that the conventional clamps, the kind of thing you see on the right hand side there, will only tolerate a relatively small amount of leakage or ground pipe displacement. The leakage that you're looking at on the other pictures there tends to really what we imagine in the gas industry. When you've got water leakage like that, it actually washes away the ground. So you guys in the water have got a benefit of having the excavation started for you. In the gas industry, it doesn't quite work like that. If the broken ends of the pipe are badly misaligned, as in a typical ground movement, then they provide the seal to have a clamp that realigns the pipe, as you see on the right hand side there. The clamps tend to build back into the stress that caused the breakages in the first place. And our first objective was therefore to create a clamp for the water industry with a greater angular deflection to the conventional clamps that would seal at live pressure and did not require the broken ends of the pipe to be realigned. Can you have the next slide, please? So there you see the kind of thing that we've developed. And it's the principle of our Aqua system. And we incorporate a reinforcement into the hard molded polymer half shell, creating an accurate but economic 3D manufacturing method. The shells are bolted together and form a loose fit around the pipe. And then we can cater up to 20 degrees movement of misalignment. Built into each half shell is a rubber membrane. The shell body has a hole through to the inner rubber lining, and a settable resin is injected from a hand-operated dispenser into the shell that displaces the rubber lining to squeeze the rubber and gently but firmly form an exact profile of the pipe that stops the leakage. Within a few minutes, the resin cures to a tough but flexible solid polymer, holding the pipe pressure without placing undue pressure on the pipe system. Next slide, please. Okay, so here you see what we've carried out as a repair, and then we've cut the thing in half. So we've got a loose fit clamp, which means that you've got a wider range of clamps. It copes with ovality, corrosion, and misalignment, high amounts of misalignment. The inner sleeve is filled with this settable resin, which you can see as the white material that deforms the rubber lining and provides the exact profile to give a seal to the broken pipe. This resin cures to an exact fit. The result is a robust sealing system that remains under pressure without building stress back into the pipe system. Next slide, please. So what we've shown here is examples of the pinhole corrosion that we were asked, could we repair these? Could we provide a sealing method for these without stopping the leak, without doing anything? And the answer to that was yes. We had a video inclusion within our presentation, which was a minute long, and we felt that it was just a little bit too lengthy. It was a little bit too long, so we took it out. So we can show that, and it shows how this exact type of leak is sealed with using this method. Next slide, please. Okay, so in summary then, what we have is Aqua, which tolerates angular ground misalignment, corrosion pitting and pipe ovality by injecting a settable resin between the clamp and the rubber sleeve. Our method does not put the stress back into the pipe system. The resin clamp will not corrode. The injected liquid does not come into contact with the leaking water. Next slide, please. Here you can see, using our Aqua technology, we can produce a variety of different leaking requirements. What we're showing there is a 90-degree elbow. We 3D print these, make them in resin, line them with a rubber lining on the inside, so we can cope with a variety of different shapes and sizes. I think in summary, and this is my last bit before Jez takes back over, but in summary, we're able to deal with the nightmare water problem scenarios that Jez was talking about earlier on. They're the sort of things that are our bread and butter within the gas industry, and we hope that we can bring that kind of technology and that experience, 40 years of experience, into the water industry. Okay, thank you. Next slide.
Okay, thanks, Mike. So yeah, just to round off, we just wanted to say that we are making lots of you guys aware of our latest innovation, and we're actually looking for a partner to drive this innovation forward. So we'd be pleased to hear from anybody that would like to form a partnership. So that concludes our presentation today. Thank you very much.
Thank you, and a great timing as well. But we've got time for some Q&A, I think, before we kind of run into the major Q&A sessions. So just relating to that particular one. So really interesting, and I like that this kind of this filler that you've got coming in, this resin that comes in behind and kind of effectively provides a custom joint around it. If we had a gap there, so sometimes you find not only do pipes kind of shift, but they may also pull. Have you looked at all on how large a gap you'd be able to bridge with this system?
Okay, shall I answer that one, Jez? Yeah, yes. What we've done there is, within the gas industry knowledge that we know, we generally would look at the amount of gas leakage with a pipe displacement. But from our understanding, you could really cope with, because the sleeve is loose, you could cope with thousands of litres a minute. There's no real issue with that. It can. We designed it to cope with high volumes of leakage. If you're trying to get a sleeve to fit closely around the pipe to start with, we encountered problems with the amount of leakage and pressure of water. But if you make it very loose and then inflate the pipe down inflate the sleeve down onto the pipe, it's a very simple process, and you would have seen that if you would have got the video.
And then secondly, in terms of materials side, what materials would you recommend this for?
The materials that we use are basically polyurethanes, can be epoxies, and we might be sorry,
I meant what pipe materials, Mike?
Well,
pipe materials?
Polyethylene, ductile iron, anything like that. The way in which the technique grips the pipe gently, we're using this within the gas industry to repair damaged polyethylene. And what it does is it tends to very gently squeeze the PE. If you get a pipe clamp that's too strong, with too much compressive stress, it actually extrudes the PE from under the pipe. So we know, and the leak tends to return, whereas this technique, it just doesn't do that.
Guy, I've just seen your comment there on, Guy has asked, does this make things repairable that might otherwise need a cutout? And that's exactly what I was looking at it for. That's where I think that there's great benefit, but I think there's even more than that because of this ability to kind of customize a fit around something. You can imagine that being used on kind of flat flanges, anything else. I think this is a kind of technology that potentially could be expanded into other areas. Okay, look, that's really great. Thank you so much to Mike and to Jez for taking us through that. If everybody just stays online now, because what we're going to do is kind of go into a wider discussion session now. There's certain bits I will come back to individual companies and just ask you to go through some more stuff with some of the questions we've had. But I just want to start out with some general stuff there. One of the comments we've had, and we've been looking here at the kind of tethered and free swimming devices that go down pipes. And on all of these things, generally we're looking at a single pipe. Okay, and it's going down a single pipe and it's either listening or it's fixing or doing something like that. But obviously within our DMAs, we don't have a single pipe. We've got a network out there. So how do we deal with complex networks where you've got multiple, branches coming off and things like that? So I'm kind of opening that up to all of the panel here. If you'd like to chip in and say your thoughts on how we deal with complex networks.
Hi, Jeremy. It's Fabio. My screen's not working, but I think it's down to design. From design of the network, you've got to put your insertion points on the network. You've got to plan for this because we should be learning lessons from many years of fitting pipes, but we're not. We're just going down the same route of replacing pipes for new pipes. That's why we've looked at new pipe leak detection and pipe assessment on new pipes. And crazily enough, in some countries now, they're just replacing all their pipes to solve non-revenue water leakage, but they're not realising that all the new pipes are leaking worse than the old pipes. So down to quality control and installation techniques. So the answer is you've got to plan into it. You've got to put cables and pull things through pipes to do complex systems.
Yeah, I think, Jez, as well, just to add to that, I'd say, a risk approach, don't start off with an ambition of surveying the whole network or the whole trunk main network in one go. Start with, put the asset management hat on and look at the high risk sections of main, look at the areas that are prone to fail or at high risk of failing, and start with those and get the infrastructure in place. Completely agree with Fabio there about new networks and designing, but with the existing networks, if you think there's a need, then actually get to grips and really know those assets, and then start to make the right interventions, whether it's repair or replace or reline or whatever the solution is.
That's why, Jeremy, we're doing the camera service of Welsh Water zonal studies. So we're doing next 2 amps, doing 10 years of work on inserting our cameras into existing assets, because all of this work in pipe, free floating, tethered, everything, the most expensive part typically is the civils work, is digging a hole, putting a big chamber in there for £100,000 on a trunk main. I know you can reuse many years in advance, but it's the expensive part. So we are doing the non-invasive, we're trying to make our technology work with your network, apart from other companies saying, make your network work with our technology. So, we're realistic here and say we're doing 1,000 surveys now through existing fire hydrants for Welsh Water. So hopefully other companies will follow suit and look at the pipes first before they clean, line, and replace. So, it's the future.
Thank you, Fabio. Kirill, can I bring you in here? Because I was just seeing your comments there. And I think this is one of the other bits that we talk about with we were talking about free swimming robots and the idea of having multiple ones out there. But it's not just having, one swarm going down. Your kind of vision is to actually be continually almost injecting and then receiving these on the network. Is that correct?
Indeed. We do need multiple robots, because otherwise we would rely heavily on humans to carry out the survey and make interpretation of data. So having robots permanently one way or another in the system over a long period of time will solve a lot of problems. Another application may be a fiber optic cable sensing. For example, if Fabio is saying that he lays cable already, so can well lay a fiber optic cable, which solve another problem. So we can actually use distributed sensing at the same time to navigate robot to particular problems, but also to help communicate and deliver power.
Absolutely, yeah. We've actually done live installations of cables in live old. So we've fit these cables into old new pipes. We've also done live installation and live extraction in live pipes. So that's what we've done in other countries. So like Hong Kong was float down 4.3 kilometers, extract it live. So that could be a fiber optic cable with sensing, as you say. So, we've already got technology here to hand.
It won't happen overnight. We need a bit of sorry.
That's right. I was just going to bring in Michael here. Michael, you've done a lot of work in terms of trying to insert things into the network and seen all the struggles. In terms of how can we do things better within our networks to actually make the introduction of devices easier in the future? What should we be looking at? Michael, you're on mute at the moment. I don't know if you're trying to speak.
Me.
Tell you what, out there. So let me put that to the rest of the panel then. If we're going to be introducing devices, what should we be doing with our networks that we're building at the moment? Okay, so how do we build networks that in this time it's so much easier for us to bring things in on our networks?
You're on mute now,
Sorry, I was going to say, I think one of the key things is starting to look to design the new networks that are genuinely leak-free first, but then secondary is having the access points and the monitoring in place. So I think the key consideration is let's try and design the networks that don't leak. I think that's something we're acutely aware of in the UK. So for me, it's those two points that are important. But
yeah, Glenn, I could see you were trying to speak there, Glenn.
Glenn?
No, again, I'll open that one up then on a wider thing. Anybody else want to chip in on how do we design our networks for the future?
Well, you're right. It's like, for example, some time ago. remember when we didn't have any disabled access in any building? So now it's compulsory. The same we have to do for inspection of underground pipes. Provide a robot-friendly infrastructure, which might be much cheaper, considerably cheaper, than to retrofit.
Yeah, and I'd agree that. And I think that's something that we need to be starting to talk to our asset side, and in terms of how we lay pipe, and when we're doing repairs in pipes, that we're actually putting access points in at those times. So we start to rethink about this entire network. One of the things I look at is, I've got this job. How do we get to zero leakage in 2050? And you're like, what's the chances of that? Because we know we're not going to replace our pipe network, in the next 30 years. But what I look at is I go, okay, how can we change how we're passing water down that network? And the analogy I often use on that is cars. If you've ever driven one of the new kind of smart cars, and we hired one out for a mate of mine for his birthday recently, a Tesla. And he went to change lanes and the car wouldn't change lane because the sensors around that car said there's somebody sitting on the offside and there's a danger you may collide with them. So it physically wouldn't allow him to change lanes into a dangerous position. So let's say 20, 30 years time, we've trickled down that technology to everybody's car, and suddenly we've got a road network where it's very, very hard to have a crash. Not impossible, but really difficult to do it because everything within that network is saying, right, we will make sure that we manage the way. So instead of trying to change all of our pipes, change how we pass water and other devices down our pipes, and suddenly we end up with a system where we're going, okay, we're not going to change all of our pipes in the same way as they don't change all of the roads. What we do is change how we pass things down those pipes. We look at calm systems, and we look at systems that can go down and repair as they're going and take surveys as they're going through. So for me, this is a real area that we need to be looking at from leakage. We're not going to replace those pipes. Let's come up with better ways of managing what's out there. That leads neatly onto the repair side. So we've talked about repairs on small diameter pipe, and Michael's been talking about the Aqua and the systems that we got there for doing internal repairs. But it's a real step to start to go up to the large diameter stuff and say, how do we carry out repairs internally on a large diameter pipe? Great, because obviously we then don't have to excavate. Has anybody in the panel kind of been looking at that, got ideas on how we can do repairs on large diameter?
Yeah, we have Jeremy, Fabio here, Pipebot. So basically, I mean, it's not about, you still need an access point though. So again, back to your smart networks, you still need, whatever you do internally, whether it's free floated or tethered, you need an entry point. So, and maybe an exit point. So it's part of the design procedure. But again, I think what will happen is, I mean, even now, I mean, people get to, I want new technology. We've already got technology. We've got so much technology in our business, which countries, the people are looking at, when they still want to go to the next thing. But before you get to the next thing, let's look at what's here and now to use on the network. So I think WRC is the same as us. They've been here for many years like we have, and people are all still using it. They'd rather dig a hole instead. So, I mean, what's the numbers on dry digs in the industry? It's still, to this day. So, this insertion points, the repair side of things, you can do. I mean, I'd look at the high cost, high risk repair. So say you've got a busy road junction, the cost of that maybe above a certain amount of money. You then tap the main on a grass verge close by, and then you can internally repair that leak from the grass verge. So you've turned a £500,000 repair to probably a £100,000 repair. So I think those sort of scenarios could be here pretty quickly, by an in-pipe solution. But you've got to look at, risk rewards and probably legislation. I mean, even today, they're digging up thousands of boundary boxes on the water network for proof of boundary leakage, and that costs like between £800 and £1,000 a dig. Just to tell the client, the customer, that bit of pipe's not leaking. So we've got tools now to tell you that with no dig for that solution. And same as Aqua guys, they can do the repairs for it. So technology is here now, today, before pushing to new things. But it's all about entry points, on the networks, whether it's for inspection, leak detection, or even cleaning, cleaning and lining as well. There's all needs for this. So it's just smart networks.
I agree with Fabio.
Thank you. Michael,
yes, sorry, I was just going to say I agree with Fabio on the inspection insertion points. There's that many technologies out there at the moment that we're all going to need them. So if we could have these sort of dotted about, ready to be used, if there's ever a problem with the pipework, it's easy accessible. And just quickly on the water main side of things, I can't sort of say too much, but it's something we are working on at the moment for water mains. It's always been our goal to reach the water mains and repair from inside the pipe, which we are.
Really good to hear that, Michael. So, Michael, there were a whole load of questions about the Aquanab that came through. So, and we've got a little time now just to kind of go into that. So, can you just describe to us again the actual process with the Aquanab and how that works? Let me just explain to everybody else why this interest in this kind of technology, and indeed in any of these technologies, is because one of the areas that we're looking at is micro excavation. So, every time we try and repair a pipe at the moment, we're pretty much digging out a big hole. Okay, and people talk about Victorian pipe systems, but the method that we're using to carry out repairs is the same one that the Romans used. Dig a big hole, cut out the bad bit and piece through. Okay, so we've got to find better ways of doing it. Micro excavation is exactly the same as you think about when you talk about microsurgery. Yeah, rather than taking out a big hole, try and do it on a small hole. But there's 3 problems that you've got to solve to be able to do that. Number 1 is you've got to be able to locate within centimeters. Okay, you can't go stabbing all over the place to try and find out where the leak is. Number 2 is you've got to excavate in a wet environment. Now, most of the micro excavations we've already seen from the gas guys, which are in dry environments. We've got a wet environment, we're going to end up with an egg-shaped hole. Okay, and then number 3, you've got to carry out a repair down that wet hole. Okay, which is going to be tricky and difficult to do because you may not be able to see visually what's going on at the same time. So there's 3 problems we've got to solve to be able to do micro excavation. But hey, there's a great prize if we can do that one. So the reason why I'm really interested in what Michael's talking about and some of the other presentations we've seen where we talk about location and it being really accurate in terms of location is that it allows us to look at these micro excavation techniques. So long lead in there, Michael. Michael, would you like to explain a bit more about the Aquanab?
Yeah, so the Aquanab, it's primarily for plastic pipes, which I think we'll all know here is very difficult to locate, which you mentioned, you pointed on there, being accurate and pinpointing the leak is very important because sometimes, and I've been to site myself where you can see water coming out of the ground, so you'll start digging there, but it could be 20, 30 meters away. It just finds its way out. So what you want to do is pinpoint the actual location of the leak. So as you say, with the micro excavations, if that's the best way to do it, you're straight down on the leak to do a quick repair.
So isolate at the far end of the main, you've got to isolate a section, and then, you know, I know with the Aqua P, you've got to turn off the internal stopcock. So with an Aquanab, I'm assuming you've got to isolate the pipe at the other end and then allow this ball to be drawn to the leak, correct?
Yeah, that's correct, Jeremy. I think it's important to be in control of the water main. A shut-off will be necessary, but if you can control that by opening valves elsewhere, you can minimise the impact from that. You need to know it's a free-swimming device. You need to have the confidence to know where it's going to be. So having a hydrant downstream and upstream, a valve either side, redirecting the main gives you control on that section of main. So you can work on that main without any worries. And
how long, Michael, generally would someone need to isolate the supply from, you know, in order to be able to get that location point? How quickly does it flow down the main to get that leak?
To pinpoint the leak, to mark it, and to get it back out, an hour at most.
Okay. So once we've actually got that ball has then been drawn to the leak and it's just sitting there, effectively that's the location, isn't it? Because the ball is sending out a signal and you detect the ball, correct?
Yes.
Would you be able to get any idea of the size of the leak? Because obviously you've now plugged the leak effectively slightly by having a ball over it. Is that not going to indicate how much the leak has dropped?
No. I had a question earlier that asked if there was multiple leaks, would it find the largest leak? Well, it would. It would go to the largest leak, but that's how you would want to repair the leaks anyway. There might be 4 or 5 leaks on a section of main. You would want to repair that largest leak first anyway. Mm-hmm. So it's better if you can pinpoint that leak, dig down and excavate that leak, or retrieve the Aquanab, then excavate and repair the leak. And if you have to repeat the process through once you've tested your DMA, then just do the same process again.
Mm. Okay, and in terms of accuracy, what accuracy are you finding?
It's within 2 feet. So a normal meter-sized hole would locate it.
Excellent. Thank you very much for that, Michael. So I was just going to go to Glenn as well. And one of the questions that came in was talking about how many kilometres of pipe have been done using your various methods and things like that. And I can see that you've answered that one. But I wanted to ask you something else as well on that one. is about, do you see there being a role for multiple sensors? And it's interesting when you look at the Sahara was generally just, you know, an acoustic device, but now you seem to be expanding out. If I'm going to put something down the pipe, I pick up multiple bits of information. Do you see that is the way it's going to be going?
Yeah, definitely. Because I think if you're going to look at something like acoustics, you know, why wouldn't you just go and put in acoustic sensors or hydrophones or something like that? So for me, if you're going to go to the trouble of putting something in the pipe, you want to glean as much information as you survey, whether it's having a look at gross metal loss or other pockets of air in there, other jointing issues, getting some CCTV imagery, you know, try and capture as much as you can to make it worthwhile. And then you're making the best decision. Are you doing a single repair? Are there multiple points you need to repair? Are you then looking at relining? You can make a much more informed decision having gathered that information. So my view is, you know, don't just look at that stuff as a leak detection solution. I think that's probably the worst way of looking at it. Look at it as a way of finding a leak, but also a way of understanding condition and some of the risks to that particular asset.
Fine. And Nicole, is that something that, as you start to look at the Pipebots going in, are you looking at the kind of sensor technology and which sensors you think would be particularly useful?
Yeah, we're certainly looking at a range of sensing technologies. Maybe Kirill wants to come in at that point because he's involved in that work stream.
Yeah, it's a sensor fusion is important. I fully agree with Glenn. So if you put something inside, it's nice to have a plurality. The most useful sensors we find for water pipes will be acoustic or visual, maybe thermal cameras as well. Also, some ideas about detecting the leaks, small leaks, using whiskers. You know, kind of like little probes, which sails use. This technology has been developed for robots in the past. So combining all these 3 or 4 technologies will provide a robot which may definitely find the leak in the right place and estimate the severity.
Thank you. Yeah, and I think, you know, it does seem to be this move in terms of the sensor technology. I'm really interested as well is in pipe condition. I think that's another part of prevent, and if we're putting sensors down pipes, then we start to try and understand pipe condition. Is anybody, you know, are you aware? And again, I kind of put in Glenn and Nicole here. Is anybody, you know, and Kira, are you looking at the kind of pipe condition assessment side of that as well?
Nicole, probably you better to say because it's theme 7 and theme 8.
Yeah. So we're definitely looking at pipe condition, but obviously also recognizing that that's probably one of the most challenging aspects. So it is one of our case studies, and the leakage detection is only a subset. But you sort of, the asset condition is clearly quite broad. So what are we specifically looking for? And this is where the multiple sensors come into play, because they all have their pros and cons and can detect different types of conditions. So are we talking about pitting? Are we talking about cracks? Are we talking about holes? What we're looking for? And then it's also making sense of the data. So if you look at a thinning or wall thinning, for example, it's a question of when does it become a noticeable parameter that you do need to take action upon, and when is it still within the functionality of the system.
Hey, Jeremy, can I say a few things on the condition assessment?
Fantastic, Fabio.
Yeah,
go ahead.
basically, so on the data side of things, yeah, you're right. We're passing a sensor down a pipe of 1,000 meters. The whole work's been done. So the more data you give the client, the better. So we've got the CCTV, the acoustics, you've got the temperature, the pressures, that's already combined. The next stage is going to be NDT, so things like pipe wall, non-destructive testing, and things like ultrasonics, which we could make tomorrow, but it's all about who's going to spend the money on this sort of technology, because we've got about 10 tools now ready for market and we're using around the world, but people always want more. They'll say, can you do 2 kilometers, can you do 10 kilometers? And again, it's jumping boundaries forward. So it all depends on what the budget is there for people to want this technology, because you can make yourself a £10 million pipe inspection robot device, and then what's your day rate to use it? What's the cost per cable damage where you do a survey down 1,000 meters? You know, all these costs need to be replaced. So R&D and the future technology we can bring to market tomorrow, but it has to be paid for by industry. So we've gone down a route of making tools that only people want, not just ideas and concepts in the future, because that's the route to the bottom. We're trying to say, well, what's needed in the industry? Where do we fit in the industry? And like I say, not one tool will do all. There's numerous technologies out there, and it's a big world out there. So, but everyone wants more than a new thing. But yeah, we can make ultrasonics now in our technology quite easily. But who's paying for it? That's probably the question.
That's a really good point, Fabio, is they've got to be cost effective, what we're doing. I think what's really nice is seeing a kind of portfolio of projects here, that we look at things that are available, kind of almost available off the shelf now at a certain level of technology. And yet at the same time, what we've been looking at today is some kind of long-term stuff that we're looking at that we need to develop, over a longer time period. And I'm very happy about that we've got that range of solutions out there. So final little bit here is a quick, we've got 1 minute from each of you, okay? What I'd like you to consider is this. At the moment, these kind of technologies that we're talking about are the exception rather than rule. Okay, you've all come across that within your own companies. You're trying to go into water companies and say, we want you to use this, and they look at it and do okay? And it's a bit of the exception rather than the rule. Now, Peter's just joined us, I can see down there. So I want you to imagine you're Peter, okay? I want you to imagine that you're the CEO of a water company, okay? What one thing would you implement within your company to help the introduction of these kinds of solutions, repair techniques that we've been talking about? I'll kind of kick off. I'm going to go through you one at a time in the order that we did that. So think of one thing that you would introduce. So Michael, I'm afraid to put you on the spot first, but what would you do?
Sorry, you broke up there, Jeremy, to implement these solutions.
What would you, if you were the CEO of a water company, what would you do to introduce, to enhance bringing in these kind of solutions into the water industry?
I think I would build confidence through the company, through trialing. Trialing's got very, very important. I think one thing I would do is speed up the process. I think it's generally that water companies are particularly slow in adopting technology, so I would speed that up. And I don't know, I think I would just sort of say anymore.
Michael, that's great. Okay, I think that's a really good point, though, is speed up the adoption of the technologies, trialing out stuff and doing some really good stuff on that. Glenn, over to you. What would you be doing if you were CEO?
In terms of leakage overall, or just this bit of it?
No, in terms of repair technologies, let's look at that kind of that location repair side that we've been talking about. So finding those leaks, the kind of insertion and in-pipe solution.
I think for me, the big problem, I think, is already started to be overcome. And I've mentioned at the start of my slides about the historic methodology for reporting, and particularly if companies were using the burst and background methodology for trunk mains assessments, then trunk mains estimation, then that was a real turn off, because if you went and the more you looked and the more you found, the more it pushed the number up. So those sort of days are sort of moving to sort of be behind us now. So I think that's helpful in itself, because it pushes people to say this isn't just about leakage reduction, it's about demand reduction overall. So we need to actually go out there and save water. So I think in terms of repair, just knowing the assets, I think it's key. We've talked a lot about data science and asset management, and I think it's key to sort of start there. Don't just go diving in and spending loads of money looking in pipes. Actually start with an understanding of what's likely to fail, where is it likely to fail, which are the most critical assets. Start with the stuff that is likely to cause you pain, and then sort of work down the list. I think that's key. And then over time, I think I'd love to see some in-pipe repair technology developing. We've seen some interesting stuff with robots and things like that. I think something at some point's got to change, and I think what can come from other sectors as well. That's something I'd really like to see over the course of this AMP period developing.
Great, thank you, Glenn. Fabio, over to you, and quickly, we're running out of time, so.
Okay, quickly. Well, I think on new pipes plan. So basically, any new schemes, put some insertion points on all your new networks from day one, because of the old histories, you've got problems on big pipes. So planning new pipes, some insertion points for cleaning, repair, inspection, everything. On old pipes, risk assess what's the biggest, hit to industry, to customer outage, and then again put some insertion points there. And then Jeremy, you mentioned a key thing there. You repair a pipe. Why don't you put why don't you repair this pipe with a UPT, a T? So that's now a new insertion point on, you could factor that with JS to be a point of interest to then, well, the hole's there already, let's make a T to the surface as a future insertion point. And again, with the correlation, the dry digs is huge still in the industry. So every time you get a dry dig, you've got to, if you get a dry dig, tap the main, find the leak, so you turn your dry digs to a wet dig. So you've solved the problem, key problem. Survey the main both directions as far as you can to update JS for every joint on that network for future records and learn from it. It's all a learning process,
Thanks, Fabio. Nicole, Kirill.
Do you want to go first, Nicole?
Yeah, I think get involved in innovation early and also look at long-term benefits. So I think looking at not just sort of direct costs, but also the sort of indirect costs, so that leads to sort of more changes in business models to really facilitate this. So just not look at in our case, at the cost of swarms of robots, but actually look at the benefits of it, which are much broader than just the technology side, just the leakage or condition assessment side.
Yeah, well, Fabio is right. To make infrastructure friendly for this kind of technology is important. Eventually, somebody will come with technology which are irresistible. When actually they can't say no because it's so efficient and so simple to use. So, but they have to get infrastructure ready for that.
Brilliant. Thank you, Kirill. Can I just stop you there because I'm aware of time? So final one from Jez and Mike.
Okay, well, what I do is I, as a CEO, I'd sit down and say, okay, so what's the extent of the problem? How many problems do we get of this nature, of this type? And tell this company, MW Polymers, that's the kind of product you've got to make to fit this. So give us a technical specification, please.
Brilliant. Thank you very much, Mike. So that's it in terms of the final fix. Listen, thank you so much for taking part in this. Some great questions coming through, and hopefully that's been useful to you as well. And now I'm going to hand back over to Peter.
Thank you.
Great.
Yes, thank you, everybody there. I've enjoyed all of that, and with a toolbox of what did we have? Flow Rider, Pluto, Aquapes, Pipe Diver, Aquatight. What can't we do? But that's magic, and I've taken some steers from that last conversation as well. And I loved your Tesla analogy, Jez, as well. Great stuff.